Welcome and study with Tanzania Institute of Education.
Salt solutions react directly with sodium hydroxide solution. There are salts which form insoluble precipitate in excess of sodium hydroxide solution and those which dissolve in excess of sodium hydroxide solution. Aim: to examine the products of reaction between salt solutions and sodium hydroxide solution. Requirements: apparatus, 6 test tubes, 1 dropper, and 1 rack. Chemicals: lead 2 nitrate solution, zinc nitrate solution, calcium chloride solution, copper nitrate solution, iron 2 sulfate solution, iron 3 chloride solution, and sodium hydroxide solution. Procedure: label the test tubes. The first test tube label A, the second one label B, the third one label C, the fourth one label D, the fifth one label E, and the last one label F. To test tube A, put solution lead nitrate. Then add sodium hydroxide solution, few drops until in excess. Then observe the changes. In excess of sodium hydroxide, the salt which formed soluble in excess of sodium hydroxide. Then take the second test tube, put zinc nitrate solution, add few drops of sodium hydroxide solution till in excess. Then observe the changes. In test tube B, you will find that in addition of sodium hydroxide solution, there's a formation of zinc hydroxide which is soluble in excess of sodium hydroxide solution. Take test tube C, put salt solution calcium chloride, then add few drops of sodium hydroxide solution, and observe these changes. After that, required to add more sodium hydroxide say changes. In excess of sodium hydroxide, there is a formation of calcium hydroxide, which is insoluble in excess of sodium hydroxide. Take test tube D, put copper nitrate solution to test tube D, then add few drops of sodium hydroxide solution. Observe the changes. Then add more sodium hydroxide solution. In excess of sodium hydroxide solution, there is a formation of insoluble copper hydroxide. Take test tube E, put solution iron 2 sulfate. Then add few drops of sodium hydroxide solution. Then add more sodium hydroxide solution. In test tube E, in excess of sodium hydroxide solution, there is a formation of iron 2 hydroxide, which is insoluble. In the last test tube F, put solution iron 3 chloride and add sodium hydroxide solution and dropwise. Then we add an excess sodium hydroxide. In excess of sodium hydroxide solution, there is a formation of iron 3 hydroxide, which is insoluble in sodium hydroxide solution. When you use sodium hydroxide solution, lead nitrate in dropwise will get will form white precipitate and soluble in excess. For zinc nitrate, in dropwise there is a formation of white precipitate which is soluble in excess. For calcium chloride, there is a formation of white precipitate insoluble in excess. When you add sodium hydroxide to copper nitrate solution, there is a formation of blue precipitate insoluble in excess. In addition of sodium hydroxide to iron 2 sulfate solution, there is a formation of green precipitate insoluble in excess and turn brown on the surface. In addition of sodium hydroxide solution to iron 3 chloride solution, there is a formation of reddish brown precipitate insoluble in excess. Conclusion: cations which form precipitates may easily be identified by reaction with sodium hydroxide solution. Another experiment: precipitation of ions from their solution by using ammonium hydroxide. Introduction: salt solution react differently with ammonium hydroxide solution. There are salts which form insoluble precipitate in excess of ammonium hydroxide solution, and those which dissolve in excess of ammonium solution. Aim: to examine the products of reaction between salt solution and ammonia solution. Requirements: apparatus, 6 test tubes, 1 dropper, and 1 rack. Chemicals: lead nitrate solution, zinc nitrate solution, calcium chloride solution, copper nitrate, iron 2 sulfate solution, iron 3 chloride solution, and ammonium hydroxide solution. Procedure: label the first test tube A, the second one label B, the third one label C, the fourth one label D, the fifth one label E, and the last one label F. Take test tube A, put lead nitrate solution, add ammonium hydroxide solution in dropwise, then in excess. In excess of ammonium hydroxide, there is a formation of lead hydroxide which is insoluble. Take test tube B, put zinc nitrate solution, add few drops of ammonium hydroxide, in excess of ammonium hydroxide to zinc nitrate solution, which is soluble in ammonium hydroxide solution. Take test tube C, put calcium chloride solution, add ammonium hydroxide solution in dropwise, in excess of ammonium hydroxide, there is a formation of calcium hydroxide which is insoluble in ammonium hydroxide solution. Take test tube D, put copper nitrate solution, add few drops of ammonia solution, Add the ammonium hydroxide in excess. In excess of ammonium hydroxide solution, there is a formation of copper hydroxide, which is soluble in ammonium hydroxide. Take test tube E, then put iron 2 sulfate solution, add few drops of ammonium hydroxide solution, the ammonium hydroxide solution in excess. In addition of ammonium hydroxide solution, there is a formation of insoluble iron 2 hydroxide. Take the last test tube, which is test tube F, put iron 3 chloride solution, add few drops of ammonium hydroxide solution, then add more ammonium hydroxide solution, in excess of ammonium hydroxide solution, there is a formation of insoluble iron 3 hydroxide. Expected results. By using ammonium hydroxide reagent to lead nitrate solution, there is a formation of white precipitate insoluble in excess. Ammonium hydroxide solution, if added to zinc nitrate solution, there is a formation of white precipitate soluble in excess. In addition of ammonium solution to calcium chloride solution, there is a formation of white precipitate insoluble in excess. In addition of ammonium hydroxide solution to copper nitrate solution, there is a formation of pale blue precipitate which dissolve in excess to form deep blue solution. In addition of iron 2 sulfate, dirty green precipitate insoluble in excess was formed. On the addition of ammonium hydroxide solution to iron 3 chloride solution, there is a formation of reddish brown precipitate insoluble in excess. Conclusion: cations which form precipitates may easily be identified by reaction with ammonium hydroxide solution.